each of these quadratics, these trinomials, will factorize into 2, or the product of 2 brackets. So straight away we can write these brackets in. Because we have a 1x squared term, we're going to get a single x here and a single x here, so the product of that will give us the x squared. Now we're looking for 2 numbers that when you multiply them you get 10, but when you add those 2 numbers you get a positive 7. And it's the same idea for each of these. So 2 numbers that when you multiply you get 10, you add to get 7 is 2 and 5. So in here we write plus 2 and plus 5. And you can expand this bracket to check that you get the original. Same again, this second one. 2 numbers that multiply to get positive 25, but when you add them you get minus 10. So we can write our double bracket straight away, an x there and an x there, because the product of x and x is x squared. And 2 numbers that multiply to 25 but add to minus 10 is minus 5 and minus 5. And we could actually express this as the square of x minus 5. In the next one we want 2 numbers that multiply to minus or negative 36 but add to positive 5. Straight away again we can write our double bracket. We've got a single x there and a single x there, because the product of x and x is x squared. Now the 2 numbers that multiply to make negative 36 but add to get positive 5 are 9 and minus 4. Here 2 numbers that multiply to get negative 36 but add to get negative 5, very similar to what we had before in the previous one. We've still got our single x's because the product of x and x is x squared. This time instead of a positive 5 we've got a negative 5, so we're going to have negative 9 and positive 4. Here we have a quadratic or a trinomial that has a coefficient of x squared that isn't 1. But notice that 2 is a factor of all 3 terms. So if we take 2 out as a factor, we're left with x squared minus 4x plus 3. Now this bit here in the brackets can be factorised straight away into a pair of brackets like this. So we've got x and x there because the product of x and x is x squared. And we're looking for 2 numbers that multiply to plus 3, but the sum of those numbers is negative 4. And those numbers are negative 1 and negative 3. And we could check that expansion and see if we get the original one. A slightly trickier one that doesn't have a coefficient of 1 for the x squared term is 3x squared minus 11x plus 6. Well, we could try this by inspection, and so the only way we're going to get a 3x squared is by multiplying 3x and x, because the only factors of 3 are 3 and 1, because it's a prime number. Now we need 2 numbers here that have a product of 6, but when you expand the brackets you get negative 11x. It's quite tricky to do in your head. We will try negative 2 and negative 3. So when we multiply this out, if we expand these brackets, we would have negative 2x by x, which is negative 2x, and we would have 3x by negative 3, which is negative 9x, and the sum of those is negative 11x. So actually this expansion would work. So this is correct. But this is quite tricky to do, and in the exam it's a lot of pressure. So there is another method, and it goes like this. Same question, 3x squared minus 11x plus 6. And what we do is we look for a number that when you multiply it together you get 18, and that's the product of 3 and 6, or the coefficient of x squared and the constant. And when we add it together we get negative 11. And those numbers are negative 2 multiplied by negative 9, because the sum of that, negative 2 plus negative 9, is negative 11. So we take this and we split our minus 11x into these two components. So we have 3, this is equal to 3x squared minus 2x, or I could write minus 9x. I'm going to write minus 9x first because it's going to make factorising a little bit more straightforward in a moment. Minus 2x and then plus 6. So these two are equivalent, they're equal here. Equals, now I can group these, I can factorise by grouping. So in the first two terms I've got a common factor of 3x, that leaves me with x minus 3. And these final two terms I've got a common factor of, if I take a factor of negative 2 out, I will be left in the inside the brackets with x and negative 3. And now we can see by the grouping that we've got x minus 3 as a common factor, and in the other bracket we'll have 3x minus 2, and that is the same result that we had earlier when we tried to do it by inspection.